All right, so we're going to be looking at another warm up, another check in to kind of get us ready for today's lesson. So, looking at number one, it says select all the following that are factors of 5n squared minus 30n. So, since I want to know what the factors are, guess what? That means we're going to factor this. So, first we start with our coefficients 50 and, or 5 and 30. The GCF of 5 and 30 is 5, so that's going to hang out up front. Then I'm going to break down my variables. I have n squared, which is n, and then n. They both have one n in common. So that means 5n is going to go out front. And then I'm going to put all my leftovers back in parentheses. 5 divided by 5 will give me 1 with a leftover n. Negative 30 divided by 5 gives me negative 6 with nothing left over. So guys, these are my two factors. These two pieces are my factors. So I'm going to look for those pieces. Look, I have n minus 6. And then I'm looking for 5n right here. Okay, those are my two factors, my two pieces. Alrighty, very similar. Looking at number two, it says what is the greatest common factor of 24x cubed plus 12x? First, I look at my coefficients. The coefficient or the GCF of 12 and 24 is 12, so that's going to hang out up front. And now I'm going to break down my variables. So I have x cubed, which is x, and x, and then I just have a standalone x. So that means they both have one x in common. So that means 12x is going to be my greatest common factor, which is C. All right, so that was a little bit of factoring review. Looking at the next section, this is what we did yesterday. And guys, this skill is going to be extremely important for today's lesson. So if I look at this, number 3 says we have x squared plus 6x. We want to find the C value that makes this a perfect square trinomial that completes the square. So remember, that's where we have to use the b over 2 squared formula. Well, that's not a 2. Squared. So we are going to plug in our b value, which is 6. So we're going to have 6 divided by 2 squared. Well, 6 divided by 2 is going to give me 3. Or we're going to use that number later, squared. And 3 squared is 9. So that means my perfect square trinomial is going to be x squared plus 6x plus 9 now. So now it says factor the perfect square trinomial. So we're going to think what's adding to 6, but multiplies, oops, I said 6, but it wrote a 3. So adding to 6, but multiplying to a 9. Well, if you look, that's going to be that magic number. Remember, 3 plus 3 is going to give me 6, and 3 times 3 is going to give me 9. So I have x plus 3 and x plus 3. Okay, so we know that we can write this as a binomial squared. So we're going to rewrite this as x plus 3 squared. So we're going to need to be able to do that for today. Okay, that's going to be extremely important. So same thing with the next side. We have x squared minus 10x plus. We want to know what makes this a perfect square trinomial. So we're going to do negative 10 divided by 2 squared. Negative 10 divided by 2 will give me negative 5 squared. Remember, this is that number we're going to need. A lot of you are going to jump right to the end, okay, because you know, oh, I know exactly where that number goes. And negative 5 squared is positive 25. So remember, I could skip all the way down here and do x minus 5 squared. Okay, but we're going to finish this out. So we really had x squared minus 10x plus 25. So I'm going to think what's going to add to give me a negative 10, but multiply to give me a positive 25. Well, we know that that's going to be that negative 5. So negative 5 and negative 5. So we'll have x minus 5 and x minus 5, which we wrote as x minus 5 squared. So the reason that this process is so important is because we want those equations or those binomials squared so that we can write our equations to look like this. Because remember, we can take the square root of that, whereas we couldn't do anything to something like that. Okay, so that was our goal, is that we had this x plus 3 squared so that we can take the square root of that, and then we just have a standalone x. So that's always going to be our goal. So if we were to solve this, we're going to add that 5 over. That'll cancel. So I'll have x plus 3 squared is equal to 25. And now we completed the square. We got x plus 3 squared, so now we can take the square root of both sides. The square root and the square root cancel each other out just to give me x plus 3 is equal to the square root of 25, remember, isn't just 5. We have to write it as plus or minus 5. We're going to subtract the 3 over. We'll have x is equal to, remember, we cannot combine these, so it's just going to be negative 3 plus or minus 5. And now is when we can break it up into the two separate problems. So I'll have negative 3 plus 5, and then negative 3 minus 5. So negative 3 plus 5 will give me 2. Negative 3 minus 5 gives me negative 8. So my solutions, you can write them as points, or you can put them in our solution set, is going to be negative 8 and 2. Alrighty. We're going to do the same thing with the next one. We have x minus 5 squared plus 4 equals 24. Notice we have that x minus 5 squared, so we can in the end take the square root. So we're going to start by subtracting the 4 over. So we're going to have x minus 5 squared equals 20. So here we're going to take the square root of both sides. Those will cancel, so I'll have x minus 5 is equal to, I cannot take the square root of 20. So this is where we have to break it up into its pieces. So remember, we need to know what is the largest perfect square that goes into 20. Well, I'll give you a hint. It's 4. So we're going to break that up into 4 times 5, because 4 times 5 is 20. We're going to split apart that radical, so I'll have the square root of 4 and the square root of 5. And we know that the square root of 4 is 2. So I'll have 2 square roots of 5. So when we're dealing with that equation, it's going to be plus or minus 2 square roots of 5. From here, we need to add the 5 over. And we'll have x is equal to 5 plus or minus 2 square roots of 5. And that whole chunk goes into our solution sets. Alrighty, if you have any questions, please make sure you're asking. If not, you can move on to your notes for the day.